this computer. Good morning, everyone, and welcome to April 13th, week two. Today, we want to talk about descriptive statistics, which is where you look basically at a variable and the way it looks and the information it can present to you, but you don't draw any conclusions on perhaps what would be like a larger sample or the wider population. But I did want to talk about a little bit about a subject we'll get into in a few days here, correlation, which is just looking at the way two variables relate or don't. And that can be done with continuous variables or categorical variables, like male and female, smoker, non-smoker. You can draw a correlation between two categorical variables like that, or age and income, say, two fairly continuous variables. And then we have this concept of correlation. And there are a couple of different methods we'll look into. Like I said, I don't see any real, no kidding, inferential statistics in your business questions where you would stand on the sidewalk outside your business and collect a sample of data and then infer um, your findings about that sample to a wider population, which is really just that's the underlying concepts. And then it just gets, you can get a PhD in statistics. I mean, it's uber complicated, and there's different types of data and everything, and they're always trying to find a new model. So we're just going to barely touch on it. I had uh, undergrad statistics. Good grief, 25 years ago. And I had been using it a little bit at work. And then when I was getting my doctorate, I took quantitative methods, which is constructing a research project that asks a quantitative research question. We talked a little bit about qualitative data versus quantitative. So we used a tool called SPSS, which is kind of going by the wayside. It's fairly expensive. It's not particularly user friendly. It's still taught in college statistics classes, but they're moving more and more frequently to R. It seems like, which can give you all the same answers, and it's a little bit more intuitive. But one thing I saw on the morning news, and you guys, we all see this all the time. We get presented with correlation and causation. That something causes something else, or that things are related, and the data shows this relation. And today, the example that jumped out at me was the pause that was put on I think it's the Johnson and Johnson vaccine.
I
It
just
might have been
watched that.
it might have been the AstraZeneca, but I thought it was
No,
Johnson
you're
and
right.
Johnson.
It's
Yeah,
that one.
Yeah, it's
Johnson and
Johnson.
Johnson. They put a pause on it because in a side effect manifested itself that was not apparent in the trials. They did the trials with I want to say like 10 or 11,000 people. So that was your sample size, say 10,000. And then from what happens from the data you gather on a 10,000 person sample size, you can then infer with X amount of confidence those findings to the population. You may not even know how large the population is for these for this math to work. But they found after the clinical trials, they found in 6.8 million inoculations, 6.8 million doses. That six people within they said within a short time. I think it was 48 hours. Was it Brittany? Do you remember what the window of time was that they developed a blood clot in the brain?
I heard 2 weeks.
Within two
Yeah,
weeks.
it was long. Yeah, 2 weeks.
Yeah. Okay. So there you go. So there's your data point of a sample of 6.8 million. You had an occurrence of a side effect, and I guess you would track that as like a column, you know, rash, pain at the ejection site, nausea, whatever side effects you're tracking, and it would be yes or no tracked among those 6.8 million rows of data. So they found what they're calling in layman's terms a very rare side effect, 6.8 million or six in 6.8 million. But what I always wonder, and they never they never address in morning talk show science, which is the worst way to take to take in your science. They never address how many blood clots were there in 6.8 million people that did not take the um, vaccine. So there's this very very rare side effect that they are reporting, and all in women. Yeah, well, that's starting to focus down on. So narrow that 6.8 million down, and go up there and sort each of those down to female is yes, and age range is 18 to 48, and then look at your sample size. And then go look at a broader sample from your control group, the rest of society. How many blood clots happened in women that are 18 to 48 during that time period that did not get the vaccine? So that's kind of what I'm getting at. And we ran into this, depending on your level of interest and inclination. We ran into this in COVID, um, during the pandemic. This was, to me, this was the one of the biggest, if this and maybe voting, presidential voting, were the biggest public data analysis um, debates and discussions, that you see. And it's just really interesting. The raw data is out there if you cared to, or were able to shake and bake it yourself. But like COVID results, I want to say the flu was basically non-existent this last year. The number of cases was down significantly. I don't remember the percentage. And then you got to peel the onion on that. As an analyst, you have to peel the onion on that to ask why. What is going on here? Is it less? Were there less testing? Less testing means less cases. So you got to look at positivity rate really versus over the raw number of cases. Is it that people weren't going to the hospital? People were getting tested for COVID, but were there drive-through flu tests? If you had symptoms and it came back negative, generally speaking, they don't routinely test for influenza, good old-fashioned influenza, unless you're pretty sick. And then there's some things that you
Thought they
can do.
had come out and said that it had to do with people wearing masks because of the viral,
Yeah.
not disease, but whatever you want to call it.
Yeah, so that's absolutely a plausible explanation. The frequency that people are wearing masks, any respiratory disease is going to be, um, you would think, would be lower, and they've talked about, COVID would have been worse had we not worn masks. So the flu would have been worse had we not worn masks. So yeah, there's just a lot of different ways to look at the data that's being presented, and kind of digging a little deeper to answer questions and whatnot. That's all I wanted to get at. Actually, I'm stalling because I don't want to talk about statistics. Can you tell? Was that readily apparent?
I was
No.
beginning to be suspect.
Yeah, because it was drawn on a little bit longer. Yeah, statistics. This is kind of the part of the class that I personally can't wait to just get done with and and then utilize them in some fashion. Um, so let me share now. I wish this is Zoomism. If everybody had their camera enabled, I could ask you to raise your hands and I could see them. Uh, if you've had descriptive statistics in college, let us know somehow by show of hands. Had Stats 101.
I did.
Damon, yeah, you've got a degree. Laura, you've had it.
I think I've had it. I don't know if it was specifically descriptive statistics, but it was a stats class.
No, if you had stats, you had descriptive and then inferential. Reason being the math that lets you rely on the inferential side of extrapolating uh, to a larger population kind of requires that you understand the descriptive statistics. So anyway, this is the easy part. Descriptive statistics are and particularly what we're going to be talking about here is more specifically I'm univariate, one single variable descriptive statistics. Um, so there's our overview. We'll go through some definitions, and then there are five basic things that we look at in descriptive statistics for a given variable. But then it gets more complicated than that, depending on the data type and everything. So um, I want to let you all in on a little secret. None of this information is a lock, guys. I put this this presentation, uh, my little naming convention, DAAT16 March 2021, descriptive statistics is in the fundamentals, and I think I finished it over the weekend and put it in there. So if you downloaded it before then, it's changed a little bit, but it's in there now as you are viewing it here. But in the notes, there's there's just a whole world out there to know and a whole world to provide information. If this is in your future, I would recommend some sort of more focused, much more detailed treatment of statistics than just a couple of day appetite wetter overview like we're going to have here. Um, if you can find a good stats instructor at a local community college or UA Global Online, any of those sorts of things, they'll go through it much more detailed, much more in depth with exercises so that you can actually go through and learn the math behind these measures. So I just wanted to cover it enough that we could actually apply it on your data. So here we go. So to back up a little bit, there's our definition of stats. It's basically just looking at numbers. But then they put it. This author put of the Oxford English Dictionary put a heavy emphasis on the other family of statistics, inferential statistics, inferring measures in a sample to the broader population of whatever it is. It could be, apples in an orchard. It could be human beings. Your population is another. Yeah, I'll wait till we talk about inferential to go into that. So anyway, this half of the family, descriptive statistics, and what I'm talking about today here is univariate descriptive statistics. Just gives you your most common numbers associated with a single variable. Not every measure applies to every type of data, so I think we'll have a caveat here there. But when you pull up a data set and you're looking at, you know, name it, say NBA basketball player heights, you can go to that, go to that column. There'll be a height in some unit of measure, um, very often inches. The scale matters. I mean, you'll when you're getting to know your data, you'll want to know what scale it's measured in. But you can get the mean, and these are measures of central tendency. Mean, mode, median, which are the three middles of the data. The minimum and maximum can often be very interesting depending on what the data is. If you're specifically looking for outliers, those sorts of things. Min and max, and then the range gives you a pretty good idea of how broadly spread out the data is. But variance and standard deviation are the more definitive measures of that. Yeah, and we'll go into. I got a slide each on skewness and kurtosis, which there you go. It matters, and the overall shape of the data. If you were to graph it out in a histogram or in some other chart. So central tendency. Many of you are working in statistical measures in your business questions. Beg your pardon. Where the first thing you're looking at is the average, average number of viewers of a social media advertisement, average number of subscribers that performed a certain function, average number um, of students per class um, a classroom. So there's these measures of central tendency. You've all, and this goes back to high school math. So mean is the no kidding, the total divided by the number, the total of the variable divided by the number. Median is the middle point. So if you have 50, you go to number 25 or 26. Actually, I think the median is the average. If it's an even number, you have to take the mean of the two central numbers, I believe, to get median. Mode is the most common in a categorical variable. So if it's a continuous variable, like temperature written in 3 decimal points, generally speaking, they say it has no mode, so you don't really use that one much unless it's categorical data. So those are measures of central tendency. If you hadn't had that in stats class before. This is a histogram, and we'll go into chart types next hour, I think. A histogram groups data. This could be continuous data. This say it's this bottom. We don't even say what the graphic doesn't even say what it is. Could be age. So say it's a continuous variable. Histograms, like in Excel, and generally speaking, will get data together into blocks, so that you can start to see kind of a shape of the data. And this is very close to what we would consider normal, and we'll talk about the normal curve here in a little bit, where the mean is 100, even though there's data in the 80s and data in the 110s, that average it out. 100 is not the mode necessarily of this data, to use the term loosely. But there you go. There's your mean. You add them all up, divide by the number of observations that you have. So that's fairly normal looking data. Normal is that bell curve where it's symmetrical about the mean, and the mean is at the top of the curve. Um, uh, Here's skewed data. And again, this is just an example. We don't even know what these data points are here. But your mean, your average, can be skewed, can be less valuable if the data is skewed to one side or the other because of the way the data is shaped. You 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 see frequently income and even housing prices for a given area. They'll use the median because there are enough, you know, billionaires. Like if you live in Omaha, you don't want to use mean income because Warren Buffett's out there, and and he'll throw off all your figures, just that one outlier. So depending on how the data is shaped, that's why there are these different established measures of central tendency, um, because it makes more sense to look at one versus the other. So this is an example where the mean um, isn't as meaningful necessarily as median. And I got all this cut and pasted from my favorite tutorial websites in the speaker notes. And then we've got your mode. So yeah, everybody likes chocolate more than the other flavors apparently in this scientific study. A sample of 8th graders coming out of an ice cream parlor. So that's how you do the mode. That you really can't average. You can't do a mean or on categorical data necessarily. Although there's kind of one exception, and that's Chaz and Andra work with this a lot, and that's assigning a mean to a categorical variable, which is a response to a survey. If you do a survey and the answers are 1 to 5, they call that a Likert scale. Your answers are actually in categorical variables. Strongly disagree, moderately disagree, neutral, mildly agree, strongly agree. And so people have put themselves in a category for that survey question. Do you like Don's data analysis class? You put yourself in a category when you respond to that survey. But then the temptation is to average those responses. And if you're taking them, apples to apples, identical classes, asking the exact same survey question, it can give you some good trending data. But a Likert scale is, and this is all in the research methodology literature. A Likert scale is kind of tough to deal with be outside of that because it's hard for a human brain to say, what do you mean? What's the difference between neutral and moderately agree? Then what now? Okay, now it's very subjective to say, to make somebody choose between, moderately agree and strongly agree. Well, what do you mean strongly? You know what I mean? So it's very difficult to assign like a measure of central tendency to a single survey because of the way people look at survey questions and the human mind. And this is something they covered in my doctorate, and it's in the literature. If you see a study that's based on survey data like that, the researcher will discuss that phenomenon and how they addressed the survey data. It's usually safer to say that 74% chose either agree or strongly agree, moderately or strong. So that it's easier to do that than it is to do a measure of central tendency. And that's all I've got to say about the Likert scale for now. Variability is the measures of how spread out the values are. I guess it'd be the flatness. Range is the absolute distance. You know, you can say you have data in age ranging from 20 to 80. So the range of your data is 60 years. Variance is how far they're spread out, and then standard deviation is the square root of variance, or variance squared. Got it on the next slide. Yeah, this is in English, the steps to calculate the variance. But then the standard deviation is the square of that, of variance. And standard deviation is used for a measure of how far something is from the mean. So if you've got something that's the bulk of the data, I got a slide on the next slide here. The bulk of the data is within one standard deviation, and that standard deviation is in the same units as the data itself. So if you took a random sample of the population, and it was truly random, say of their age, 68%. Age is one of those classic things that's normally distributed, and the normal data, this symmetrical data that has that particular shape where 99.7% of the data comes in within 3 standard deviations of the mean, plus or minus. So when you're using this data, the other tests, like the inferential statistics, where you say that if we give this drug on the mean reduction in, say, cholesterol, for a cholesterol drug, the mean reduction will be 10 points. You rely on normal data to do a lot of those calculations. And if your data isn't normal, if it's skewed one way or the other, you have to use other advanced methods that I'm not even capable of discussing, let alone implementing in a data analysis project. But this is the normal curve, and 68. This is where 68% of the data, regardless of what it is, of normal data, will be within one standard deviation. 95% of the data will be within 2 standard deviations. So this is where you start to see the probability in a sample of data that is normally distributed. The chances, the probability of finding something that's outside of 3 standard distributions is 3 in 1,000. So it's really rare, really difficult, and that's where that math, that likelihood, that probability of finding something outside of these 3 standard deviations becomes really rare, and that's how you assign statistical confidence that a given sample represents a change in the mean based on your experiment. So that's normal data. There are other distributions, and like I said, we'll look here in a minute at what skewness is. Any questions I can go look up for you on the normal curve and normal data and how the data is distributed? Skewness. Thank you. Like I said, this is really something that personally I just want to get through. But I'm trying to get my professor buddy, Dr. Worley, to come in and do inferential statistics for us. So skewness is just what you think. Just what you think. The data is skewed to one side or the other, so that the median and the mean are not the same as they are in a normal curve. When you've got negative skewed data, the hump is on the right, which to me was counterintuitive. To me, I would expect the opposite to be true. A positive skew, I would think, would be the hump would be on the right, but that's not the case. And the more skewed your data is, the less you can use a lot of these models. Because, like I said, inferential statistics depends on the odds, the probability of any given observation being, within that 99.7% of the time you're going to get something in that distribution within 3 standard deviations. So that's skewness. And then you've got this other phenomenon that is, skewness was left and right, misshaping of the data, correct? Kurtosis is the narrowness of the distribution, like peakiness, peakedness. So, like I said, depending on the measure of kurtosis, you have to apply different different units of measure when you are inferring to a wider population, because it's more likely, there's a higher probability for something that comes in and is platykurtic. There's a higher likelihood of variability. It's flat. You really don't know. You don't have any confidence like you do in a normal distribution of the likelihood, or you don't have as much confidence that the data is going to fall within standard deviations. This data will still have, standard deviation, variance of standard deviation, but it'll be much broader. And then the opposite is also the case. Data can come in and be leptokurtic, but narrower, skinnier. So the population's data is much more narrowly defined than it would be with a normal curve. And then the overall shape, this next slide just gives you a pretty good visual of what that data would look like. And again, we use a histogram in our charting tool to look at the shape of the data. And you can kind of eyeball it, but there are also, the numbers involved. So you got normal, and again, skewed. A uniform distribution is you have equal numbers of the same observation throughout I don't know when that ever comes in. Bimodal would be like if you went to that's very rarely in nature, you know what I mean? But it can happen depending on what you're looking at. Like if you went to a childcare center and took the age of everybody that you found, you would see a bimodal distribution, because you'd have the teachers in one on one side and the students on the other, or same for elementary school, whatever. So you can find bimodal distributions occurring naturally, and they can be multimodal. Things are either group A, B, or C, and there's very little in between the data. But when you do a histogram of it, it comes out, and that could be like a failures kind of look a little bit. If you look at the curve of failures in electronic devices, they have a particular distribution that's called the bathtub curve. Things tend to either fail immediately as soon as you turn it on because of some flaw in the manufacture of an electronic component. So things either fail, they call it infant mortality of an electronic component. They either fail right away, then they last, or they don't, and they last, and you see that failure rate drop off, and it stays steady until the end of the expected engineered whatever lifespan of that component, and then you start to see them spike pretty quickly. So there's just different shapes of distributions out there in different kinds of data. So those are statistical measures, but you guys are also looking at, I mean, there's just a lot of different ways to look at data and tell a story about it and to say something about it. Like this doesn't really necessarily cover like rates, like, consumption rates or subscription rates. The difference between last month and the month before was, plus 5% of subscription, or in a classroom environment, the grades this quarter were 3% worse than last time, whatever the case may be. So you've got these rates and ratios and other measures that are not necessarily a univariate descriptive statistic, although some of these are applied. So we are coming up magically on the break. So Thomas, it's almost like I was stalling for just the right amount of time. So I'm going to leave this up while we're on break, and when we come back, I'm going to hopefully get enough volunteers that I don't have to call names. But I want to talk about how these measures affect you at work. What measures that we just talked about come into play? What are they used for? How do you measure it? Where's the data come from? What is the metric? How do you deal with any sort of oddness in the data, whether it's skewed data or outliers? Sometimes outliers, that data point well outside the the normal curve or whatever. Sometimes that can be something that you want to act on. You can go, ooh, that's a good thing. Let's go find out how that happened and make more of those. Sometimes it's an error and you have to throw it out. So we'll go on break until 9:30. Any questions or concerns? All pretty elementary stuff, right? Okay, but we got to cover it. Can't finish a data analysis course without talking about good old-fashioned statistics. Okay, we'll take a break till 9:30, guys. And I will pause the recording. Thank you, and welcome back from break. And we'll just get started now for the first time. Not like we've been talking for 15 minutes and I forgot to hit record. Okay, so yeah, continuing the discussion about descriptive statistics, and so that even what Damon was talking about, like the average number, the average number of people with COPD in a given geographic area. Damon, is that something you're calculating from the raw data, or is that demographic data in a database that already has that number, that 6% of the people in 72118 have COPD?
So what we'll have every member, and then we'll have kind of a flag for them. It'll be like a binary, I guess you could say it's a binary variable. It'll be like a 0 if they don't have diabetes. It'll be a 1 if they do. And then I'll run like an aggregate command in R, and I'll do the mean for it. And sometimes I'll do the sum. but I'll do the mean for it. And if they're all numeric variables that I'm trying to do, I can select GeoID to be the thing that it aggregates by, and then it'll kind of throw everybody who has the same GeoID together in one row and give me the average for them in that GeoID. And then I can take that to something. I use a package called TMap, and it lets me pretty much layer, I guess you could say, different variables into a map. Does that make any sense?
Sure. Yeah, I've seen like in Tableau, I've seen geographic data. It knows what to do with it, and it lets you, yeah, it lets you drill down interactively into to closer and closer down into, like, zip codes and whatnot. I think it was a VRBO, average prices of a VRBO, and Tableau just, it has a built-in geo information service, so it lets you interact with it more or less off the shelf. Pretty magic stuff. So cool. That's all you're doing, all that in R.
Yeah, that's just what I've been using now. I actually haven't really used Tableau too much, except for in one class that I took, but we just dabbled in it a little bit. So that's something I'd like to kind of explore at some point and get better at.
There you go. Well, sky's the limit. There's just time and initiative. It's just incredible the amount of information out there. It used to be you had to go to the bookstore and buy an actual paper Sam's publishing book, or teach yourself whatever in 21 days. And now, man, it's just the amount of things that you can learn is just staggering. I get super intimidated by how much there is to know out there. Who else? Let's talk. Priyanka, what are you? Where are you seeing these sorts of things applying in at Waco Media?
So we do not get a chance to apply everything what we learn at college, but definitely predictive analytics is something which is helping me a lot these days. And somewhere on predictive analytics.
What about the descriptive statistics that we're talking about here? Are you seeing?
Not really at this point of time, because it's been just 3 weeks. I joined Waco. Might be at later point of time for sure.
Okay, yeah, that's right. You're a brand new hire, Aaron. You're the numbers guru everybody defers to, aren't you?
I guess I don't know that I'm a guru, but
guru, you are a guru.
I guess some areas.
He's a guru.
He's a guru. He doesn't want to admit it.
What
are you seeing in these areas?
Definitely lots of averages. I had a really hard time thinking of anything else that we use, but things would be like our average monthly visitors, our average monthly paywall visits. So these are people, how many people are seeing our paywall every month on average, average time on page, average page views per session, our average monthly rate. So we've got some people getting in at starting at maybe $1 a month, and then we've got people who are starting at $34 a month, and just figuring out what the average is across our entire subscriber base. Okay,
well, let me pick on you, because those are great answers, and you mentioned several things that I wanted to that you mentioned several things that examine facets of what we went over. Like you talked about average time on a page. Was that the metric?
Yeah.
Okay. So how does, that, say the average is, 20 seconds or whatever. How does variability play into that? How does this, the standard deviation of that? Is it, they spend, 90 seconds on a page with a standard deviation of 40 seconds, which would be wildly varied, you know what I mean? It'd be a huge variation. or does the tool you're using even look into those sort of things? Does it show
It
outliers?
does not. So like I'm using Google Analytics for that, and they automatically calculate that average time on page. So I'm not sure if I could come up with that or not.
I wonder, because like I said, one outlier, one person that sits and stares at a page and comes back to it and goes off and Google's something about it and comes back to that article and goes off and Google's this, fact check something else, factchecker.org or whatever, and comes back to it and spends, 2 hours on that web page. If everybody else's average is, 15 to 20 seconds, if you took him away and everyone else's average was, 20 seconds with a standard deviation of 2 seconds, one standard deviation away from the mean would be 2 seconds. That 2 hour guy, depending on how much data you have, could skew those results like crazy. But I understand if you're pulling the data from a third party tool, or it doesn't take it, all it's looking at is mean. You don't have the same flexibility to visualize those sorts of things as you would if you did have that. So I'm just curious how that might come into play.
We probably could get that from BlueConic, Aaron, at some point. We probably could. So I know things I've looked at for Chattanooga, I've looked at the outliers of like time on site through like custom reporting. What do you think, Aaron? Do you think that, like, do you understand what I'm saying?
I don't think BlueConic I don't think that it has a timer that's counting on site. I know that they have they're doing an average. I believe they're doing an average time on site.
Oh, okay. Is that what that is?
Yeah.
Okay.
It might be possible, but I would have to look into it.
Sure. And this is, guys, this is just food for thought. The kind of the academic part of this discussion, so that and in some rule sets you could just throw it out. Like if you had literally, you had the 2 or 3 hour person in what was otherwise a group of people spending 15 to 20 seconds on something, that's going to denormalize your data. That's going to skew things. It's going to one element, one observation is what you would call maybe a row in Excel. That one observation, that one data point is going to skew the results like crazy. So you could eliminate it. And I'm pretty sure I've seen in some tools that if there's a certain percentage of the sample, or a raw number, like I say, if there's if there's 4 or 5 things, you can remove them from the sample, and it will shift things closer to normal, because you figure those are anomalies. It's either bad data, or like I said, it's your one crazy web user that's keeping a page active for forever and ever, where the vast majority of your of your readers, you don't necessarily want to take action based on that one person. So that can be the effect of outliers, and you just have to decide as the analyst what you're going to do with them, or if you're even going to take them into consideration. But it's always something to think about. Okay, well, okay, so that is univariate descriptive statistics. Those 5 measures form the bulk of that world. And like I said, the normal shape, the normal curve here, where 99.7% of your data falls within this 3 standard deviations. And you've got the math for standard deviation. If but all these tools calculate this stuff for you. So you don't usually have to worry too much about computing the math, but interpreting it is another issue. So it's good to, if you're dealing with this sort of stuff, it's good to know the basic theory. But I recommend a quality college class if you really want to have credibility when you're discussing this stuff. Or hopefully you've got somebody on staff that has the analytical mathematical background. That's for me as an IT guy. That's my biggest weakness is in math. I mean, I can program, or could develop a whiz bang management information system, with reports and data entry screens and tables and columns and rows and all that. But like I said, I've only had 2 stats classes in my life, and my 1 year doing analysis, I never really even had to worry about it. It was the business questions I was answering were more about the data itself, not and sorting the data, ordering things so that you knew what priorities were, not necessarily doing any sort of large calculations, particularly with things like skewness or kurtosis. Just never really had to deal with it. But there you go. We're in an analysis class. Check, we covered it. So next I wanted to go into just real quick some basic chart types, and then pull up Excel for a little bit. I want you guys to to use Excel. To use this Excel Bible and the data set that I posted. I'll cover that real quick here after I talk about charts. Any questions on this stuff? All the links I put in the speaker notes are smarter at it than I am, really. Any comments on the applicability of this? Okay, silence is golden, I guess. Let me put this away, stop share, and hey, I didn't pick on you, Laura. You just gotta tell us a little bit about that, if you don't mind, about Udacity's nanodegree and what you thought about that experience.
Yeah, actually they cover descriptive statistics and how to use that in Excel in particular for analysis. So the business analytics program has like a couple of weeks on that. And I use it in my role. I just came on here at White Spider, but one thing I'm starting on is how, so Walmart assigns a quality score to each of their products. So how well it fits like certain specifications, like for certain products, they require comparison charts. For certain products like pharmaceutical, like over-the-counter medications, they require ingredients lists and like how well it fits within regulations. So I've been doing a distribution of the quality scores for different brands and for different categories, just to see like for our clients what the competitive landscape looks like in terms of how strong the quality of product scores is.
Are you seeing a tight grouping in those quality scores? Or
It's a really normal distribution. So yeah, and like for our clients, the goal is that they're mostly distributed to high quality scores. But yeah, like in terms of when you bring in, because Walmart has, I think, over 1 million products. I haven't analyzed, obviously, the full data set. We've been working within like certain categories. But if you look at the full categories, like all of the products, the quality scores are normally distributed. But then if you look at what's ranking high, like in the top page or top 2 pages, that distribution looks different.
Okay. And just for all of our professional development information, there's, like I said, there's any number of sources out there. You can take a college class. There's YouTube videos for free. Udacity is somebody I just became aware of here in the last 3-4 months. For everybody else, they offer programs that they call a nano degree in a given topic, and it's pretty wide as far as IT and analytics. So, uh, Laura, what did yours a nano degree?
Yeah, I did 2 nano degrees. They're 3 months and they're project-based programs. You don't have to complete them in 3 months, but that's kind of their recommended guideline.
Mm.
And so each one covers 5 to 6 different units. The business nano degree did descriptive statistics, Tableau, Excel. See if I can, I did that one last year. And then there's like a capstone where you kind of combine all of those into a final project with like, they give you a business question and you apply all of it. So I recommend it because it is project-based and they do have like real people who grade your work and give you feedback that you can ask questions, talk to. So the way that they do that is, like you actually have to apply everything in with sample business questions.
Okay, cool. So worth the time, worth the money.
Yeah, they give scholarships too if you can apply for financial aid. I think it's affordable and you can move faster through the material if you don't want to pay as much,
Yeah, it's a
so
monthly, it's like a
your
monthly subscription, right?
Yeah. Mm-hmm. I think it's worth it. And because you get that live feedback, and even if you submit like your work and it's all correct, they still give you suggestions. Like, have you thought about it this way? Have you tried this, this approach? So having that like actual interaction with a real person helps, I think.
Okay. Yeah, it's Udacity. They're UDACITY, udacity.com.
Yep.
And I've heard, haven't heard anything bad. They aren't the cheapest out there, but I'm now that I've looked into it, I get emails, so they often offer discounts. But if you guys, that's why they call them a nano degree. It's not necessarily college credit. There may be some that are, but it's intended to be short-term focused training to fill a particular need that you might have. Some of them are more general than others. They seem to do a pretty good job at staying away from like a Microsoft certification or a particular language, and it seems to be more almost more academic, where it's tool agnostic somewhat. But anyway, thanks for the rundown. If you guys are looking for more professional development opportunity, Udacity seems to be getting pretty good marks out there.
I think they have a Python course and they also have machine learning and AI too. So like if that's in our advanced topics, something that anyone wants to learn more,
Sure.
I've thought about it.
we'll just introduce it. Depending on what you're doing, machine learning is or is not really analytics, really, to me. But I just know the basics. All right. So yeah, I wanted to go into charts for just a little bit, and then pull up Excel for just a little bit and do a quick turn. Let's put away descriptive statistics and bring up chart types. And you guys have all seen these. I'm just going to go over the book learning segment. But we've got there's a whole chapter in our book on charting. Share screen. And these are basic visualizations. There are certainly more out there. And Excel for example, we'll do recommended charts. It'll look at the column or columns that you have selected and magically walk you through it like it does everything else, you know. It's auto magic, I call it, which can be great and it can be frustrating. So yeah, charts. So got your good old fashioned column chart, and this is a great way uh, to compare two or more variables within like along a time sequence or some other sort of x-axis, like maybe departments at your organization. It's particularly good for date value though. And then you'll see in Excel and R and Python libraries have different flavors of these things. There's a different different flavors. You can stack the columns on top of each other, so it's more like a pie chart in that column, you know, where it shows parts of a whole. And we'll use Excel for this kind of stuff. So that's a column chart. It's not a histogram. A histogram, like I said, is more about the shape of the data in bins. Excel calls them. Then you got a line chart. This is a great way to show stuff over time. Have any of you guys, do you guys use a line chart? I mean, you can, it doesn't have to be time. It could be, generally speaking, there's got to be an order to the x-axis. So it's got to be over years or quarters or age in years or something like, you know what I mean? There's got to be an order to the stuff on the x-axis so that the charting tool knows what to do with it.
We use line charts a lot at Waco.
Looking at what sort of variables, Brittany?
Retention over time, or if we're trying to reconcile stuff, Aaron will throw the information on a line chart so we can see like where the big like errors in data are. What else, Aaron? I mean, I am over retention, so I do line charts for, you know, how subscriptions perform over time compared to other subscriptions. So if we have like an offer of like $34, $32, $30, and then put them all on a line chart and compare how they performed over time.
So how they perform, let go into a little bit more detail on that. So you've got a time sequence on the x-axis, right?
So for all subscriptions that started in January, say, we have 3 offers for an example, 3 offers, $34, $32, and $30. So we start in January and we track their retention over time. So if each one had 100 subscribers, it started in January on the offer, that's 300 total. And then we would track like February, how many did we have on each? March, how many did we have on each? And then just like continue that trend, like, I mean, for an indefinite amount of time, just so we can see like at, 9 months, did the $34 people retain better, or did the 32 or 30? So I look at that a lot.
Okay, so you're not looking at raw numbers of those offers because those can increase each month, right? Because with new subscribers, you're looking at retention. So you are talking about the same subscriber either sustaining their subscription or dropping off.
Yeah.
So you're looking at a count of subscribers,
Mm-hmm.
and it either, so it can't increase. You're just looking for it to decrease as little as possible on
Right.
the chart. And what tool are you using to do that analysis?
We use Data Studio.
Okay.
The Google platform.
Oh, okay. There you go. Yeah. Okay. So yeah, that great example. But again, it's over time. So you gotta have some sort of order in that X axis in order to kind of, pair up the data and make it work. All right, line charts. And the much maligned pie chart. I didn't realize until I like a year ago when I started putting this course together, how much bad bad press a pie chart gets. But if you're showing parts of a whole, uh, really the pie chart stands out. But the things um, that it doesn't do really well is since there's no real scale on the outside, it can be tough for the human being. So you got to make sure you've got decent labels on it, so that you know how big, like this blue wedge is here. Um, it means you need to label each of these pie slices. And the other weakness of it is if you get too many pie slices, it looks like you probably seen one. You see a pie chart with 30 bands in it. It's like, okay, yeah, the data's on there. It's on a pie chart, but it's not super useful. So there's probably a better way to visualize that, and we talk a little bit more about human perception and visualization later in the course. But yeah, so if you've got a pie chart and you've got um, maybe 6, maybe 7 um, proportions or wedges in the pie categories: bears, dolphins, and whales; lions, tigers, and bears in our example. 6 or 7, probably shows a reasonable and the real story that I see is like dolphins are well more than half of whatever that it kind of depends on the data storytelling effort that you're going into, when to use a pie chart. There are other things like that stack bar chart that show proportions of a whole that may be more useful, but again, these are just tools in your toolbox, so use them this is a bar chart, use them as you will. Bar chart's a whole lot like um, a column chart, only horizontally, and it's really good for categorical data. I love this. I don't know where I found this graphic, but excuses for being late to class. I had no clean pants to wear. But again, the bar chart shows the raw data. It doesn't show them necessarily um, side by side and in a proportion, as far as it's, I had no clean pants to wear is what percentage of the whole of all students' excuses. So again, use them at your discretion. I had no clean pants to wear. Hopefully that's just somebody's good sense of humor. But these all seem very reasonable. I'm trying to think, when my kids were going to school, I forgot to set my alarm. That's definitely one. Anyway, bar chart, horizontal bar chart. And then you don't see this one as much. It's an area chart. It kind of shows the proportion of the whole among multiple variables. One little weakness, though, is when one variable ducks behind the other, um, it can disappear unless you do something like we see in this shaded area where you see that data behind the front data. So it can be good, almost like a pie chart for showing proportions of a whole. But again, it just kind of depends on your application. Now in the speaker notes, when you download these and you get a chance, there's a particularly cool area chart that may or may not be cool to you or useful to you, but I thought it was cool, showing how genres of music come and go, and there's a link to it here in the speaker notes. I thought it was pretty interesting. And then the good old histogram. This is what you'll use generally for pulling up continuous data that you want to stick in bins. So Excel will automatically default to a given number of bins based on your data. It's pretty smart. And a histogram just shows you, how many people are in like the bin of 5'7". There are 3 observations in the data, 3 folks in that data that are 5'7". There are exactly 6 that are 5'8", and so on. And a histogram kind of will give you an idea of the data, and it'll really quickly show you if it's fairly normal, if it's by chance, if it's that bimodal, like we talked about, the students and the teachers at a school would give you a kind of a bimodal histogram. But that's super useful for showing the shape of the data. If it looks kind of normal, if it's super peaky, if there's quite a bit of outliers, there may be some outlier group, outlier category that's going to skew your analysis. That's a histogram. And then box and whisker is something you'll see in no kidding, statistical analysis. But this is a box plot, a box and whisker plot. This will show you pretty much everything we talked about in the descriptive statistics section for a variable, for a data point. No, not a data point, for a variable, a column, say, in of continuous data in Excel. It gives you the minimum value, the maximum value, and the median. And then it goes out to these Q1 and Q3 are the quartiles. So it can show you how, try and get on camera here, it'll show you how skewed the data is. And the min and the max are at the end of the whisker, is what they call that. And it'll show you how far you have like outlier data. So this box and whisker plot that they're showing on the screen here is for an absolutely perfect normal data set that's pristine. Very rarely will you see something like that. So a box and whisker plot, there's another one, I would call it more advanced. It's called a violin chart. Shows you very similar data, but it gives you a little bit more information on the distribution of the data. And then I wanted to stick to univariate statistics, these single value charts, but there is the old scatter plot when you're looking at things, something like salary and car. You would think, right? You would think that as someone's salary increases from left to right here, you would think the car that they would deem worthy of themselves would increase, right? Generally speaking. But then these scatter plots will show, classically they'll show the correlation. The statistical value is R, 1 being perfectly correlated. And that means, no kidding, for every dollar you increase in salary, you increase the price of the car by $1. And they are perfectly correlated. That would be a score of 1. And if they're negatively correlated, it would be -1. So correlation is measured from -1 to 1. And it's looking at 2 variables, 2 continuous variables. So we'll work a little bit more on those. So, okay, we come to our second break. It is 10:18. So we'll come back 10:32 or so, and I'll pull up Excel and make sure that you guys have access to your textbook and the data files, and we'll just pull up Excel and do a little run through. And then I want to spend the rest of the day doing a little bit more thorough overview of in Python. So hopefully you've been able to download and install Anaconda. If you have not, please take the next 15 minutes to do that, or shoot me a private chat or an email or something like that, and let me know. But I'm gonna bring up some Python in that third hour, or our final hour. Okay, blah blah blah. Man, have you noticed how much I talk? Have you noticed that? It's like endless. It's like all day long he talks, each word more useless than the one before. Sorry, that's an Adam Sandler impression from Saturday Night Live with Chris Farley. Okay, let's take a break till 10:35. 10:35 cell phone time. Okay, welcome back from break. I was looking at different ways to use Python to calculate distances, and then from there you can do whatever processing you want. And yeah, using an application programming interface, you just got to get the parameters right and everything. I'm sorry, guys, I forgot to hit resume recording. Okay, so I've asked a couple of folks, what tool are you using? I haven't run into anybody saying I'm using Excel all day, every day. Anybody want to come off mute and tell me I use Excel all day, every day?
We don't use Excel, but we use Google Sheets.
Google Sheets. Okay, Gabe, what does Google Sheets, for if you don't know, Google Sheets is Google's web-based equivalent of Excel. May not be quite as powerful, but it does all the major stuff. What do you guys use it for, Gabe?
When everybody started working from home, we made them all their own Google Sheets. So it transfers everything from a main page onto their page. So it's got their bonuses, their monitoring scores, stuff like that on them so they can see them.
Now, are these students or employees that are using this?
Customer service reps. So
Okay.
they're employees.
Okay. Internally or internally within the company?
Within the company, yeah.
Yeah. Okay. Yeah. Google Sheets. If you, especially if you want to work on something with someone, if you haven't seen the Google products work, they're pretty magical as far as just real time collaboration. They're a little frustrating to me. I work in Google Apps, Google Suite, and Office. Kind of at the same time, or you know what I mean, co-equally, and invariably, unless it's a super simple document, you download it out of Google Docs and it won't look the same in Word, and same with PowerPoint, and they're a little frustrating. But okay, so I wanted to pull up share screen. Wanted to pull up, I guess.
Oh, hey, Don,
Hey,
by the
Ted.
way.
Oh, by the way,
Yeah, when I was trying to get to that Excel Bible, apparently my organization won't let me.
you gotta
They're pretty stingy about anything outside.
you gotta
Chaz and
person.
I had the same issue. So what Chaz did is she went to print, and then if it's not connected to a printer, you can save it as PDF.
Mhm.
Or what I did is when you open it, it'll let you open it and then right click and save as, or you can do that way, whichever.
But see, I can't even, whenever I try to access it, the first click, it doesn't, it gives me a security error.
Yeah, I'm trying to think. I'm trying to think of how to get you a downloadable link. For whatever reason, it wouldn't let me post it in the classroom. But it should just be a downloadable, link to a PDF. Can you now? Is it the computer itself, or is it your account? You know what I mean? If I added your personal Gmail, can you access your personal Gmail at work?
No.
Ah, smart. I mean, that's tighter security. It's 50 megs. I don't know. Can you attach something that big to an email?
I don't know. I kind
Can
of,
you zip it first? Do you
yeah, I
have
was gonna
a,
say if you zipped it maybe, but
I'll look into that. I'll do that on the next break or this afternoon, Thomas, to make sure you guys get it. It's not, I mean, I'll get it to you one way or the other. If I gotta stick it on a thumb drive and drive it to you, I'll figure out how to get it to you.
okay.
But in the classroom, I wanted to make sure you guys saw this in the front matter of that book. It gives you a website where you can download a zip file of sample data sheets, just a whole bunch of stuff. Hang on just a minute. share my screen. Yeah, okay, go ahead and share our screen. And if we go over to the classroom, there's still some clutter here. I got to get rid of these objects. I don't even really remember where they came from in Blackboard. Down here under the Excel, data analysis with Excel. Oh, here's another thing. Thomas, have you got the classroom? Are you logged into the classroom, Thomas?
Yes, I am.
If you are, click on this link. I think I actually added this and failed to publish it until this morning. Click on that link and see if it brings up like an e-reader version. That may be the solution, the quickest, easiest solution to getting it on your computer or getting access to it at work. And then underneath that, see this complete book worksheet.zip.
Mhm.
For everyone, that is a zip file that has a ton of worksheets in it.
So I'm able to see it in this Internet Archive piece here.
In the e-reader, yeah. So when you're at work, until we get it figured out, that's the book. I mean, it's the same format.
Yeah.
I was able to download it in PDF. Like I said, I believe it was from academia.edu, which makes it easier for me to distribute. But if you guys are in any sort of a situation and that PDF isn't available or whatever, the link up here should work. I guess, depending on your security settings at work. But then hopefully you guys will be able to download this zip file and to unzip it, or if you have to, do that at work and bring it in on a thumb drive or however you can get it into your environment. I don't necessarily know. I mean, we're certainly not going to be going through this entire book of 1,000 pages. But if you use Excel all day, so the magic of Excel or any other spreadsheet is, as an individual analyst, if you just if to just go in and wrangle some data, to go in, look at some charts, do some stats, find the min, the max, the median, transform a column, from say you had two values for two dates, but you needed to know what the percentage of increase or decrease was. You can go in and add another column that transforms or derives data from those. So it's a fantastic tool for an individual data analyst. Where it runs into weaknesses is that it's manual, pretty much. I mean, you can learn how to use macros and automate stuff, but most folks move on to some sort of coding language if they're going to be automating a sequence of steps over and over again, and using that for analysis. But so there you go. So Gabe came off mic and admitted to using Sheets, which is a spreadsheet, on a daily basis. None of you are like Excel, you're in Excel, 3, 4, 5 hours a day, or even 3, 4 times a day, running through a data sheet.
I'm in Excel a lot. I wouldn't
Okay.
say all day, every day, but at least every day.
Okay.
Yeah, I think eventually I will be. Currently I'm not, but I'm pretty sure use it 30, 40% of the time, depending on who's asking for the data.
Okay. Well, like I said, we've got the Excel Bible there that will run you through really virtually every menu option, every function, every facet. I'm going to do a couple of tours of it, and I'm trying to contract with a no kidding Excel guru. I may need to lean on you guys. I had COVID happen. I had a business analyst with statistical and Excel experience that was supposed to be handling this part of the course. and COVID happened to the entire family. I told you guys in the intro, fellow named Travis. So anyway, Excel. Let's see. I'm basically gonna talk about it for a little bit based on, inspired by chapter 1 in the book. But I kind of feel like I'm wasting my time here. We'll see. Okay, so I want to stop sharing my entire screen and share that window. And by wasting my time, I mean wasting your time. I've been using Excel for 20 years, but I don't use it anywhere near as much as Laura does. When I get curious about something, I'll go in and figure it out. I used it when I was the Coding Academy director to look at like class size for each cohort we would have. We had 5 classes a year. So I went into Salesforce and I had to munge the data to get down to, having a reliable number of students that, entered, graduated, or dropped the class, and then run some charts and whatnot. So I can get it to do what I need it to do, pretty much like any, office worker, knowledge worker. But I'm certainly no guru. If by chance any of you are acquainted with like a corporate trainer that trains in Excel and can run through some of these like tips and techniques, please shoot me an email. It's a paying gig. So yeah, we gotta, you pop,
Don,
ma'am.
sorry to interrupt you, Priyanka here. So in case if you can share, format paint, space special is the best shortcut all of us can use, especially when we have the formulas or the values of formatting. Space special is, the savior for everyone.
I agree. What Priyanka's talking about is well, we'll do a little bit of that here in just a minute. Okay, so you've got a this is Excel. The basic constructs of it are the file that everything is saved in is a workbook. Each individual tab is called a worksheet. So I want to say you can save individual files, and you'll see a lot of data sets out there that are in XLS format. It's just a single worksheet. It's just a single sheet of data in your classic columnar data, which is a heading at the top and rows of data. You can rename the sheet. Right click on anything, just like in any Windows interface, and you can rename it. Who's working on a Mac? You guys from Waco work on Macs, right?
Yes.
Yeah.
When you're in an Office product, or when you're, what's your alternative to the right click and the menu that comes up whenever you right click? Context sensitive right click menu. What's the Mac equivalent to that?
Just Control on the keypad, and then click on the sheet, and it usually will let you rename or delete or modify the sheet.
Okay, Chase. Yeah, Control click. So yeah, when you see a menu pop up automatically, that's me right clicking. If I forget to say that. So yeah, so and then you can add as many sheets as you want. The best practice when you're working with data is to have the sheet to be as small and focused and clean as possible. So if you're working with a worksheet that's got 70 columns times 2,000 rows, generally speaking, that data can become distracting. It's difficult to bounce around from column to column to column. So you want to work in as focused a worksheet as possible, and that's where you start cutting and pasting columns from sheet to sheet. Okay, so yeah, you've got columns and rows. The columns start at A, go to Z, and then start over again with A B to AZ, all the way out to whatever it is, ZZ. Just a ridiculous amount of columns. And then, like we said in the intro, does anybody remember? It was 18 million rows. Something that your PC is just going to sit and go, because none of us are working on a workstation that can handle the maximum size of Excel. So yeah, we got worksheets, and you can start another sheet, and they'll be independent. Name that one. So in columns and rows, you've got all the usual formatting, but I have no intention of getting anywhere near making worksheets pretty. My only intention is to go over tips and techniques to look at data, to no kidding, analyze the data for yourself as an individual analyst, and maybe to create a chart that you could potentially cut and paste and share with someone. But there's a boatload of functionality to make a worksheet look pretty. If you were going to publish this as an application, or even publish it as consumable business information. So yeah, you got columns and rows. So this, when you click in a particular cell, which can contain text or data, you get the cell number up here in this box. Like like I said, loosely inspired by chapter 1, they started a column that was dedicated to month, and then I think it was, say, projected sales, doesn't matter. So you type that in. There's formatting columns for, you can change the width. You can double click up here, and it'll automatically extend the width of the cell. So most of the data that you'll be working with, if you go out to Kaggle or any of these other things and you download a data set, they almost all come with a header row. Sometimes they use a double header row, two lines for the header, which can sometimes confuse Excel and be something that you want to work into changing. You might want to look into whether or not that fits your needs. So yeah, month, you can type in that, and I want to say that it is smart enough to autofill. Yeah. So this lower right, if you're not familiar, this lower little square right there. Can everybody see that? Okay. When you grab that, I went into the next year. When you grab that and drag, it senses what you're trying to do, and that can be good, and it can be bad. So you need to pay attention to what Excel is doing for you. But it automatically, when it saw the date January, it automatically assumed, oh well, you want to, that there's a pattern there. If it would have been, let's say day, and if I typed in Monday, autofill senses that, and sure enough. So this can be really handy if you're creating like test data, or setting up something that you want to do analysis on. Don't forget about autofill. It's pretty magic. Well, and like if you work with Excel at any length, then you don't have to worry about that. You already know it. And we will cut. and then hit delete. To delete the contents of a column, generally you're going to say clear contents. Okay, so like I said, I'm following along with the chapter 1 in the book. Projected sales. We start off with a base value, and I say it was 103,000. And then in Excel, as you have with Python or any other analytical tool, you can use a formula based on that value. So we've got in cell B2, we have a value here. So the example that we're using out of the book is that projected sales are based on a formula where they are projected to increase 3.5% a month. So what you would do in here, instead of having to do that math yourself, you use an Excel formula. So to insert a formula into a cell, you select the cell, and then you go up here to the formula bar, and there's just no end of magic that can happen up here. It senses what you're typing in, gives you context sensitive help. It's just magical. But here, like in the example of the book, and I'm flying blind here, guys. I don't have the book open. You're going to say that the contents of this cell equal that's telling Excel obviously that you're using a formula. It's not the actual literal equal sign. You're using a formula equals cell B2. So you refer to the cell almost as you will see in programming languages, almost like you would a variable. So that right now, B2 is 103,000 as your baseline projection for January, right? But if you use a formula and let it cascade, let it derive that, you'll see here in a minute that it automatically calculates and recalculates those columns, which is pretty handy. So it equals B2 times, and then 103.5, say, is 3.5% growth. Did I get that math right, guys? That's not right. Three and a half percent growth would be the cell times. It's in the book. Anybody got the book up? Times.
No, but wouldn't it be times
Point
0.035?
1.035. There you go. 1 point. Yes, that is a 3.5% increase over the previous month. So you hit enter, and it does the calculation, and that passes muster, right? 3.5% increase of over 103. But then the autofill feature also sees that this is a derived value, and it'll automatically fill in the formula. But it needs to be the previous month. Yeah, it automatically backs it up. See, it bases it on the previous month. Since this calculation used the previous cell, when autofill goes through, it goes, oh, well, you must want to do that on the previous cell. So you'd have to do some machinations to have each one to use January. So you see what I mean? The formula is that sales will increase based on the previous month, but autofill kind of sees what you've done and fills that in. But let's see. And again, I'm flying blind here. No, that's not what I wanted to do. I'll have to look. Laura, anybody want to bail me out? If I wanted all of these to be a 3.5% increase over January, not over the previous month, there's an option Priyanka, is that where it's paste special, where you paste the value and you don't paste the formula?
I would do an absolute formula. So if you want it just based on January, you can turn that B2 into an absolute.
Is that a dollar B2? Is that absolute?
Yeah, that's the dollar sign.
Dollar B2. See, like I said, guys, I'm clumsy. So we created that one. Absolute means don't allow it to cascade. Don't allow it to, automatically use the previous months. This when I use this formula now, it
you may have to lock both the number and the letter. So $2 signs, like one before the two.
There you go.
There's a keyboard shortcut for that. I'm trying to remember what it is.
It's F4, I think.
Okay, so I'm going to clear all of this out. Clear contents. So we're back to empty cells here. And now if I cascade that, if I autofill that, it's not using the previous month. Yeah, it's going back to, it adjusted it for here, but then every month is now projected to just be that, because I hard coded the absolute reference up there. Anyway, again, guys, I'm pretty clumsy when it comes to Excel. I have to go out and use Google Help or whatever to get it to do what I need it to do when I need it to do it. But I don't. I'm not in there day in, day out. So I'm gonna stop. I'm gonna stop wasting your time, and make sure that you guys have Excel. You have access to either the ebook or the PDF, and the this complete book worksheet has the actual, if I can go in here and like file, open, intro to charts is one of the worksheets. This worksheet that I just pulled up, and it's not sharing that because it's a separate window. Like once you download that data set or those Excel files, in the, for example, chapter 20 goes into creating charts and other visualizations, and this file, intro to charts .xls, goes through and gives you, this is the kind of the data set that I was messing with, and then it lets you draw like this is your typical bar chart, and it steps through and it tells you what sheet to go to. Here's a typical line chart showing say like area 1 and area 2, and this would be maybe two different zip codes or two different tracks, and it shows you over time. Again, line chart almost always used with some sort of time sequence, and it shows you the varying median home prices. But all of these worksheets come with the data, but then you've got occasionally there'll be one where it tells you to do something unique. So one of the, like I said, the automagic things in Excel, you can insert, click anywhere in the chart, basically anywhere in the data, and say insert recommended charts, and it comes up with, looking at the data, it analyzes the data and gives you recommendations. Now, as we've talked about, generally speaking, data, we kind of want a line chart, right? But look at these the different charts that it would let you use if you so chose. And if you say okay, and it automatically sticks in a line chart for you based on its observation of the data. Pretty magical. So if the recommended charts, the recommendations don't work for you, and you're smarter, you're smarter than Excel is, you can always use a different type of chart. But it's pretty slick. And then once you do insert a chart, or when you're working with a chart, you have this context sensitive ribbon that shows up that allows you to choose cool looking templates and look and appearance, different design templates for that chart. So and even this one added a label to the data point, which is a chart element you may or may not want. It's not super visible. And if it were me, let me expand this a little bit bigger. To me, that's a horrible label. Generally speaking, though, you can click on them, format data labels, and maybe, again, I'm flying without a net here, guys. Label options. I'm looking for the font. Label options.
Looks like there's a text options. Could it be in there?
That let me do one. Let's see. If I get all the labels, get off of there. If I get all the labels, was that you, Gabe?
Yeah, there's
Format.
a text to the right of label options.
To the right of format data labels?
Nope, on the right side under format data labels where it
Yeah.
says label
Text options. Text options. Text fill. Solid fill color. Not white, black. There you go. Boom. So there you go. You just got to, all of this stuff is flexible. The labels on a chart, the colors of the actual, the colors of the actual lines, all of these elements, generally speaking, will be changeable. You just got to figure out exactly where the mouse click is and what you want to do with it. So there you go. So these, like I said, between the book and the sample data files, it's a pretty decent tutorial. And like I said, what I really would find most value in for you guys is I'm trying to find an Excel whiz to talk about dirty data and assembling data sets, and the tips and techniques for deriving data. Like if you got a couple of columns, but there's something between those two, like a rate or a ratio between the two columns, you definitely want to clean things up, transform data, so that you're using, it's answering your questions. But like I said, I can walk through it, but man, I'm clumsy and slow, and I do want to be respectful of your time. So, there's a ubiquitous black and white pie chart. Isn't that lovely? Yeah, you can click on these elements and and kind of change things, drag that pie slice away if that's what you want to do. Working with these things, it's really, if that's if that's going to be the way you tell stories with data, you're going to want to get really familiar with Excel charting. But depending on which tool you're using, that may or may not be an imperative, and depending on the level of management and everything. But you can cut and paste these charts, save them as a JPEG, insert it into PowerPoint or Word document or whatever. They get stagnant then. But okay, so yeah, quick tour of Excel and these basic chart types. Chapter 20 is the chart types, and the first part of the book talks about all the different elements in Excel. Like I said, a lot of this stuff is just for making things pretty, so it's not really a focus of an analytical class. Okay, so for the next hour, let's see, stop share, put that away. And man, one weakness of OneDrive is that it automatically saves this stuff often. And you may or may not, like I'm used to opening up a Word document, and I got this a love-hate relationship with OneDrive and you're working with documents on OneDrive, because it will auto save stuff that you're doing. And sometimes you're like, nah, never mind. I don't want to keep any of that. Well, too late, too bad. You'd have to retrograde to a different version and pick which version of the auto saves and everything. So I kind of, whenever I'm working on something that I'm, no kidding, going to change, and I know I'm going to change it and use a different version of it, I'll save it as a different name. But anyway, so for the next hour, for our final hour, if you would go onto the classroom and download, go down to Python, programming in Python. And let me share my screen. Here we go. Go into the classroom and then go down to the programming in Python module, and download this 02 Intro to Python and Notebook IPYNB. Thomas, your problem downloading or accessing the PDF has me concerned about how we're going to distribute class information. Are you able to download this file? If you click on it, yeah, this Intro to Python and Notebook IPYNB file. Will it let you?
Yes.
Okay, cool. Then I'll stop worrying about it. So like I said, if you go, you can do this from within Python, or you can do it. I'll stop sharing now. Everybody would please download that and put it in your Python/notebook directory, as we talked about last time. I'm going to stop sharing that, and I'm going to share my Explorer. Boom. Share. So like I said, I keep everything in OneDrive so I can work on it on multiple computers, but you can do this in Explorer, or you can do it in the Python Explorer, in the Jupyter Notebook Explorer when it comes up. But make sure you got a Python directory like I do there, OneDrive, Documents, Python, and then make sure you have a Notebooks directory underneath your Python directory. And there's a way, I can't get it to work on this computer. I was taught how to save a shortcut to Python, to Jupyter Notebook. And when it comes up, it automatically goes where you want it to go in the path, and you're messing with the path variable. But I couldn't get it to work on my home computer. So I gave up, and now when I go into Jupyter Notebook, I just click, it's a few mouse buttons, to get where I'm going. But if everybody would please create a Python folder with a notebooks subdirectory, wherever you want on your computer. It doesn't matter to me, but as long as they're in that order. And then these are all my notebooks and actually a few data files that are a little bit cluttered here. But stick that intro to Python and notebook file, that IPYNB, in your notebooks directory. And then I want to go over a little bit more in depth about Python and software engineering and whatnot for our last hour. So 11:17. Let's come back at 11:30 and go ahead and bring up Jupyter Notebook like we did before, and open that notebook. And I'll see you guys back at 11:30. And if for whatever reason you have trouble over the next 13 minutes, we'll sort it out when we come back. Okay. Back at 11:30. I'm late. Sorry, I got sucked into my email account. Just when I thought I was out, they draw me back in. Okay, so a little bit of Python, a little bit at a time. Um, every week for sure. I don't want a week to go by that we don't get into Python. And for those of you who are like, super energy charged now that you've got a Python place where you can type the code in, sky's the limit as far as going out and there's sample code all over the internet and there's tutorials. I've got, I don't know, 3 or 4 Python books somewhere in the classroom. I need to organize them and put them up in my Python programming area. But let me share my screen. I want to go through that one notebook before we adjourn for the day. But man alive, 4 hours. This is I'm wondering if this is just a bit much. What do you guys think? Is 4 hours in class? Yeah, you're okay. Gabe's like, man, it's no big deal. I'll sit here, listen to you yammer.
Either this or work. I'd rather do this.
Okay, well, I'm trying, being in the position I'm in. I'm trying to make it applicable and interesting, and and hopefully thought provoking, as opposed to just this is Excel, this is a chart, this is a formula. That sort of stuff to me is fairly mechanical, and if that's what you're into, then dig in. If that's what your task is. But the breadth of your experience and the variety of the domains that you work in, combine with the variety of the tools that we use to just make. It boggles my mind. I'm doing the best I can to put together a worthwhile course, but there's literally so much I could be choosing from that it's a little bit difficult for me to be confident. But I'm you take your best shot. Seems to be widely appealing. Most of the programs, like Laura was talking about, you learn statistics, you learn Excel, some visualization, you learn some sort of coding, whether it's R or Python. Most of the data out there in your corporate databases are going to be in a relational database, so you learn SQL. And so there you go. All right, I'll shut up and cover some Python. Okay, so I guess I need to share my whole screen. Okay, so in the Explorer view, when you first click on your Jupyter Notebook link, you will have a view like this. Um, it goes wherever your default Explorer view is. So we've seen that before. If by chance you need to move around in Explorer, you can. It doesn't. You can click up one level, go to your Python directory, go to your documents directory, go all the way up to my OneDrive. So this Jupyter Notebook Explorer view works pretty much like your file explorer in Windows. So if you did by chance, let's go to my Python directory again, Python notebooks. If for some reason you're in one of your subdirectories here and you want a subdirectory, you don't have to go back out to your file explorer. You can create a new folder right here, just like you can create a new notebook. If you click create notebook, you get that first code cell like we did on Thursday. But you can also create a folder, or if you just want to create some data or something like that, you can bring up a text file, and it's got a little text editor built into it. So this is the Explorer view, and it's pretty handy. All right, so with no further ado, pull up your 02 Intro to Python in the Jupyter Notebook. Okay, so as we talked about Thursday, there are really 3 kind of cells. We won't do raw NBC convert. I've been learning this language, for a couple of years and have not had to deal with that yet. So we won't even work with it. But we talked about, the markdown cells are great for documenting a research project or telling a story, and then you have the code. And if somebody wants to dork around with one of your parameters or use a different input file, everything's there, and it's really easy for them to change in order to replicate what you're doing. So it's pretty handy stuff. So yeah, we got these markdown cells. Here's some tutorial on this. I'll make another note I got a markdown syntax cheat sheet. That shows you all of the different formatting commands that a markdown cell knows to react to. Generally speaking, just typing will wind up looking like normal text. But then you see these header levels. If you go down to this markdown cell, where it says this is a level 1 header, this is level 2, level 3. See a pattern here? I got all these notebooks. I learned Python at University of Central Arkansas from a really great guy named Mike Ellis, who I just got to agree to do a workshop for us in June. He's got really good dry sense of humor. You can only be so funny in a college classroom without getting into trouble. So these are his notebooks basically that he gifted to me. So yeah, if you double click on that one, you start to see you put a pound sign, 2 pound signs is another level 3, and then 4. And one thing you'll notice, if you double click on the markdown cell and click right before this is a level 1 header and backspace and get rid of the space in between it and then run it again. You see what happened to the level 1 header? Don't forget to put your space in there, or it will treat it as just normal text. And then here's some more formatting. You guys can see my notebook, right?
Yes.
And for those of you that are lucky enough, if you've got 2 monitors and you can see the Zoom session, my screen share on one side and your own screen on the other. I bought a 27-inch monitor versus 2 monitors so that I can kind of split screen like that. So hopefully you can follow along with me. But this star on either side does bold. Underscore on either side does italics, and a combination star underscore is bold italics. What is this? Oh yeah, if you're writing about code in a markdown block, you got to bracket it with these 3 tick marks, or it will get confused and think you're trying to write code. So for those of you that didn't know, Python is named after Monty Python. Did anybody not know that?
I didn't know that.
There you go. It is actually named after Monty Python. And I think almost specifically Monty Python and the Holy Grail, because there's just you see a lot of references to that out there in the Python world, and it's especially
it just makes me like it more.
Yeah, there you go. If you've never seen Monty Python, you gotta. I mean, that's kind of one of those. There are movies. Oh, I am recording. Good. I don't think I ever even paused it. You get your entire break recorded for your viewing pleasure. You'll be sitting around talking to somebody, and the subject of movies will come up, and somebody will say Blazing Saddles, and you'll say, "Oh, I never saw that." Oh, you never saw that one. It can be annoying, but Monty Python and the Holy Grail is kind of one of those. I don't know. In my pantheon, probably in the top 20 or 50 of stupid movies. Stupid movies you've got to see. So if you haven't seen it, it's really stupid, but that's Monty Python. So this next markdown block shows you how to format a bulletized list. It's fairly smart as far as sensing what you're doing. And like I said, I'll upload a cheat sheet. So if you're doing something in Jupyter Notebook, you'll be able to document it, and it'll be appealing to your audience. Let's see here. Okay, here we go. We're going to do something a little bit more than a hello world. So you've all written a hello world program. So go ahead and you can cut and paste if you're so inclined, or if you want to see how typing in Python Jupyter Notebook sort of senses what you're doing in the next code. So do that that my_var equals 3 + 4 print my var. And see what you get. I'm gonna count to 10 and let you guys get that in there. So yeah. And you run it, remember, by clicking on run. But see, that's such a small cell that it was hard for you to see. But everybody see the 1 in the brackets that we talk about in the next cell. That's the order that the cell was executed. So in one of these, when you're working with a notebook, you will occasionally see, markdown code, markdown code, markdown code, markdown code. And it may be tempting to run cells out of order. But if you do, you need to realize that just because some code came in the notebook before other code, if you don't run it, it doesn't really exist. So it doesn't actually happen. So anything like a value inside of a variable like my_var, you can only count on it if you've actually executed that cell. So there's other ways to run cells. You can say cell run all, and it'll just go from the top down from that cell menu. Run cells. You can run if you get down to a cell and it's obvious that something happened previously. Maybe it could be importing a library or setting some value that you're counting on. You can run everything, run all the cells above where you're currently at in the notebook, and you can run all below. You can change the type of a cell from code to markdown or back and forth depending on what you're doing. And then another thing from this cell menu that I talked about on Thursday was cell all output clear. If you've executed these and maybe you've drawn some graphs and printed out a bunch of stuff and it's just getting really cluttered, you can always clear everything. Or like this one, current outputs, that's just looking at my current cell. If I click clear there, it gets rid of that 7 for me. So I can if I want to change it now to something else and run it, I'll get that new output, So that's the thing to remember about Jupyter Notebooks is you have these code cells, but you don't necessarily have to execute them in order. So just be aware of kind of the order of what you've got your code in and what's going on. Another thing that you'll see is an asterisk inside of that square bracket. If you see that, it means Python is processing. And some of these, as we get into this, you'll start to see that it's taking seconds, 3, 4, 20, 30, 2 minutes sometimes, to do something complex, particularly when you're importing those larger libraries. And some of these I've gone ahead and screwed up and put it in the cell for you, like this next one. Yeah, I was supposed to get you to add a code cell. So you can still do that. Click on the markdown cell that says now add a new cell below this one. And then click on insert cell below, and you get a fresh code cell. See that? That's how you get a new code or markdown cell. You insert above or below, kind of like inserting rows in a table in Word. And then this print my bar, so I'll delete that. Edit, delete cells. Okay, now this next print statement shows a string literal is what you would call this is my underscore var in quotes. And the print statement will print an unlimited number of things. You can have multiple, this is my var, and then I can add another literal that contains a value and a space, and then comma my underscore var again, because we don't have any other variables. So, and if I print that, if I run that, you see there's no well, there may be an upper limit, 64,000 or something, but anyway, when you're using a print statement, you can print multiple things. And very often when you're printing your output from a calculation or whatever, you're going to want to put nice labels around those values. And then I don't want to get ahead of myself. So there's your print statement, and you can print, a variable or a string literal or any combination of two, and that's what you get in your output. Yeah. And making the point that we didn't assign the value 9 to my var in that cell, right? We did it in the previous cell, but it's still there. These cells aren't independent programs. They add to what's going on in Python's memory, as long as you have this notebook open. Each notebook will have a separate Python kernel, so that stuff you're doing in this notebook won't goof up something that you're doing in another notebook. And I'm gonna fly without a tightrope without a net here, and I'm going to show you what I'm talking about. So right now we've got myvar that Python understands. There's this thing called myvar that we can work with, right? But if I go back to the Explorer window and I say new Python 3 notebook, I get a new fresh notebook, right? Which I can name, putting in the untitled thing, and then clicking in untitled, and I could say test of separate kernel. So this tab, this notebook, has its own kernel. So that's where in the notebook, where before I got to this saving and closing a Jupyter notebook, I wanted to explain this before we get to this next part so that you'll understand why we're doing what we're doing. Test of separate kernel. Now, if I print my var, again, I'm tightroping without a net here. I don't think this kernel, this notebook doesn't know what my var is, because this is a separate notebook. It has a separate Python brain associated with it. So I'm going to run this, and I'm hoping it's going to barf. Barf! Yay! Barf on command. This notebook does not understand what's going on in the other notebook. So when you are working in Python and you're working in separate notebooks, just be aware of that fact. So to close out this notebook that I just created called Test of Separate Kernel, we want to say File, Close, and Halt. And that closes and halts the kernel, which is associated with just that tab, just that notebook. It doesn't have any impact on the other one that we were working on. And it tries to close that tab. Boom. So it's gone. And the everything that you did in that notebook, it auto saves the notebook itself, but everything you did as far as, you know, Python's brains are concerned, are closed out appropriately. I don't think, based on last time, that we're going to be working in the kernel. If you go down that the markdown cell a little bit more, talk about interrupting and restarting the kernel and whatnot. I haven't found a need to do that yet, but I'll get into it if need be. But then, you know, take a look at at the notebook. You've got save and checkpoint, which just basically just saves on your file menu. You can download a Jupyter notebook as a PDF. So that's what I'm saying. You know, it's a great storytelling tool. If you draw a graph, you can actually normally save that off as an output file in PNG or JPEG format. Yeah, take a look at the menus across the top. Most of the commands make sense. You know what I mean? They're fairly intuitive. Move a cell up, move a cell down, merge the cell below with the one we're working on. There's different things like that. You can split a cell you're working in if you choose to for some reason. It's once you get into working with Notebook, just make sure you're checking out these different features as they become useful to you. And then you can turn the header and toolbar off and whatnot like you could. And it's just standard. These are standard Windows options. Like I said, insert cell below or above, that you're doing that frequently when you're working in Notebook. And then we've already talked about the cell menu. Lets you change the type, lets you run cells, and it lets you mess with the output of the cells. And again, kernel, I don't get into that. I do things cleanly the way I was taught. But if you're by chance, if you become an advanced Python user, you're certainly going to need to know what that does. So yeah, you can have Python 2 and 3 loaded. So some people, for whatever reason, are working in both versions of that language. So you can change. If I had Python 2 loaded, I could change between 2 and 3 there. I don't even know what widgets are. I don't even know. I'll have to look it up. And then help. Help is where, who was it that asked me, how in the heck did you know print is the output statement?
That would be me.
Andre, yeah. A lot of this stuff, it's almost like anything else. You kind of got to get up to a certain level of knowledge before the book makes any sense. And then once you know what you're looking for and you can understand the documentation, they start to make a lot more sense. But these are the official reference manuals for Python and its arguably most useful analytical libraries. Like NumPy is for working with numbers. SciPy has a bunch of scientific. Matplotlib lets you draw graphs. Pretty much every chart you can do in Excel, you can do in Matplotlib. Symbol pandas. Pandas let you work with data in a data frame. It's called. It looks a whole lot like an Excel worksheet, and you can go across and work with individual cells, or you can do a command that goes and executes the same thing across an entire column. You can work with a row of data at a time. It's pretty handy, pretty fantastic. There's some people that say that pandas is the reason Python is so so popular, but I'll let you guys decide if that's true or not. Okay, Python in the notebook. Okay, so you guys that have done some coding are going to potentially get confused. The notebook is going to be a confusing interface at first. No big deal. Because you're used to seeing code on the screen, and when you hit run, it all runs, and Notebook has these cells that break things up for you. So you just got to keep that in mind. Those of you that have never programmed before, this is kind of new and cool. The whole concept of a Jupyter notebook. Normally you would be working in just like a text editor and then, running that chunk of code, or in an IDE. And you guys actually have an integrated development environment called Spider that came with Anaconda. And if you're, adventurous, you pull it up and take a look at it yourself. I'll do a tour of it. If you're doing, data analysis, Jupyter Notebooks seems to be by far super popular as far as documenting and conducting analysis, because of the way it persists. You run a cell, you get the graph, you can scroll up and down and look at your output, and then you can publish the thing. So it's just a really cool tool. But if you're doing, like, Python can be used to replace Java in a web application. And those guys are going to be working in an integrated development environment, an IDE, of which there are several to choose from for Python. But I want to back up and talk a little bit about programming. As a data analyst, the reason to write program, to learn programming, to learn something like Python or R, are twofold. Can come into two main categories. The first reason to learn is to conduct analysis in real time, sitting here right in front of you. There is virtually nothing that you can do manually in Excel. It's just that you can't do in Python. It's just faster. I guess there are people that know, and same with R. We pulled up an Excel file in Excel, and we created a new chart. We used autofill to complete the number of months. Those sorts of things. That can be done in R. That can be done in Python, interactively. But I just don't know necessarily that you would ever get faster with it than you would in Excel. And maybe there are exceptions. Maybe, if you get used to, the statistical analysis commands in Python or R, it may seem better, faster, easier for you to sit down and interact with data in real time. So there's that reason, to perform data analysis in real time, interactively as you're working with the code. The other reason, and as a former programmer, and kind of somebody who thinks like a programmer, the main reason is to automate a sequence of steps that conform to a fairly rigid set of rules, so that you don't have to. And that's where I would use something like Python, maybe more than I would use Excel for looking at a new data set and something that I haven't looked at before, and getting the mean and drawing, like we showed, that that line chart comes up automatically, that sort of stuff. I don't know when it would ever be truly faster or easier for you in Python. But if you are working with data that's coming from multiple areas, and you're going to automate the assembly of that data and ask some questions of it and spit out some output, automating it in Python is a big reason to learn coding. But then, like I said, there's a lot of published research out there. You go out to Kaggle or GitHub is the world's largest code repository for programming of any language. You go out to GitHub, there's a huge amount of code out there that you can reuse. So it's good to know it for that reason too. So replicating, like I said, that your Jupyter Notebook allows another person to replicate what you did, or even tweak your code, that reproducibility is a big thing in research. But so as a programmer learning coding for the first time, these are my buddy Mike's 8 tenets, and they all resonate with me too. Writing good code, good programming, and what is a good program? Well, it's something that gets the job done. It gives you the correct output, but it's also something that's understandable, something that is executes in a reasonable amount of time, something that you'll understand when you come back to it. I was working with a guy last time, Xander from Lost 40, and we did a little coding for his project and didn't make it very readable. So when we came back to that code later, it was kind of hard to remember a few weeks later what it was we were doing. So that's what this rule number 1, a good program's an essay on problem solving, written for your fellow humans, written for your fellow analysts, and oh, by the way, it works on a computer. So that's a note to making sure that you use good readability in your programs, and that's meaningful variable names like my var, my underscore var, so that you're actually using something like markdown cells, or you can actually write a comment in your code that doesn't do anything but document what you were thinking at the time. Rule number 2, plan your program before you write. I got into this with my son on a C++ problem he was working on for college. And I think he started coding before he fully understood how he was going to solve the problem. If you've got your camera on, that was my English language solving a dice roll problem before I ever opened, and I did it in Python. I don't speak C++, but yeah, I went in English, and wrote out in English how I was going to solve the program, how I was going to solve the problem. For anything complex, and I'll be giving you guys from super simple to sample problems in Python for you to chew on. Plan before you write. because it starts to get goofy, the program, you know what I mean? The logic in telling that computer what to do gets complicated. And you've all heard of Fortran, right? Old programming language, Fortran. I was yelling at my computer back when I was learning back in the late 80s, and an old programmer was standing over my shoulder. I think he was my boss's boss. And I said something about, good grief. Of course of course I meant to put a semicolon on the end of the line or something like that. Doesn't this thing know what doesn't this thing know what I'm trying to do? And he said, yeah, computers don't speak DWIM-TRAN. And that's a play on the word Fortran. DWIM-TRAN is do what I mean. DWIM. They don't understand what you mean. You got to get the syntax right, and it gets complicated. So yeah, becoming a good programmer. There you go. I would, if this sort of coding is in your future, if your organization is encouraging the use of Python for its machine learning libraries, or data mining, or even data engineering, and extract, transform, and load. I was talking to an employer that wanted to do everything in Python, not in Microsoft SSIS or any of the other tools that are available. Practice, practice, practice. Do a little bit of Python every day, at least every week. So there will be conventions. They're not necessarily we're not talking about a language syntax like you got to have the comma here or whatever, but there are naming conventions and just good best practice, so that basically when you look at a Python program, it doesn't matter who it was written by, because they're kind of following, the basic conventions of the language. And they're there for a reason, and that's so that we can share code amongst each other, whether it's within your team at work or the wider programming community. Oh yeah, testing your code and test it again. That's just a note to software testing, guys. It's you can prove that it works. You might be writing a little script that does something for somebody in management, and you may get them to enter a value and then calculate or draw a graph for them or perform some calculations for them. And when you're writing that code, getting it to work is the first test, right? If I put in exactly what I'm looking for, and I will get out what I will get out what I am looking for. But then, start entering things that maybe you didn't expect, and you'll start to see why you need more testing. Test, and test it again. Your code should be self-documenting. Like I said, there are places where your code will indent automatically, pretty much by convention, which makes it easy to see kind of where the logic is branching. But meaningful variable names, so that when you're reading it, you know what it is your program is doing. And comments are important, and we'll get into that a whole bunch here in the class. They're notes to your future self, because you get into this stuff and it gets complicated. So yeah, see rule number 1. Rule number 7, all input is evil until proven otherwise validated. Yeah, you can't count on especially when you're using data files for input, not user input. You can easily get stuff that will just explode your code. So any program will likely need to have some sort of data validation. That could be, the individual answers that a user is putting in, or it could be validating an entire file to make sure that you didn't get some garbage. This next one, we will do this, but it's a little bit advanced, not terribly. A function should only do one thing. When you're writing computer code, and we're going to have to learn some advanced mid-level computer science terminology, or you won't understand how Python is working. A function should do only one thing. You can write, say, Damon and Thomas want to calculate the driving distance in miles between two Latin longs or between two street addresses. You can do that in your code, writing a long computer program. But then sometimes you want to do that exact same thing again. So to have the same code in more than one place in your code, just because you are doing that function again, you're performing that same bit of processing, is dangerous, because if something changes in that algorithm, and those 6, 8, 10, 20 lines of code may be the same in all 3, 4 places, but if you want to change what you're doing and the way it works, you have to change it in all 4 places. So rather than do that, you can write a thing called a function that you write one time, and it always does that. Now you can call it, you can call it function calculate distance, and you can call it as many times, you can use it as many times as you want in your code. But if the logic in calculate distance ever changes, you only have to change it in one place. And a function like that should be focused on doing one thing. Like I said, in that example, it would be returning a value that you can then use in your program. So there's a concept in computer science called modularity. You want to write modular code so that if something happens, you only have to go to that one module to change it. And and yes, just like Mike continuously bombarded me all semester, I will bombard you probably for the rest of this course. So there's the Python language standard. It's the same thing you run into when you go to the help and you pull up the Python reference. Okay, now I talk about logic getting complex, but everybody doing okay? We're at a normal break, but I'm just going to go for another 15 minutes and call it a day. Everybody doing all right? Okay. If you got to drop off, the record button's on, but I talk about programming being complicated, but what's the game that says it's a minute to learn, a lifetime to master? I don't know if it's Mahjong or one of those fairly simple games. There are with 3 basic types of statements in a program. You can write World of Warcraft, and there's everything in there's basically going to be one of these 3 types of statements. So the complexity comes in how they combine and how you can have them inside of each other and all the while trying to perform a specific function. But really, there's 3 types of statements. There's sequential, one after the other, one after the other, one after the other, like we have our our hello world. You can have an assignment statement where you do something like my_var equals 3 + 4. Those are all those sorts of things are called sequential statements, and they execute as they are written on the screen, doon, 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 in sequential order, until you run out of commands, and then you end the program. Sometimes you want to do one thing or the other, and that's when you have a decision operator. There are a couple in Python, and we'll get into those. But that's your basic if then else logic. If something equals 1, do this stuff. You can have 1 or more lines of code inside of that if. And then you can do else if it equals this, do something else. Else if it equals a third option, do something else. And then otherwise, all other, in all other cases, do this stuff. So you call that a decision operator, uh, most classically represented as by the if then else. And then you've got repetition or loops. And there are several different ways to write these, several different. Now he says we'll be doing almost exclusively sequential statements. That's not particularly true. When we get into data analysis, we'll be doing that. But I found that it's good to know basic looping and to be able to think like the computer thinks going in a loop. So repetition can be done in a finite number of times. Sometimes you want to do something 6 times, like the problem I told you about I was helping my son with in C++ was a dice roll game. And you had 10 turns, or each player had 4 turns. You can write a loop that executes exactly 4 times and does whatever you want it to do, and it'll do that 4 times and then be done. But you can also do repetition until a condition is met. You may want to write, like I said, if you're doing maybe an analysis project for management, you might want to write something that has kind of like a little character-based menu in it. And enter an amount or enter Q to quit. And until they type in Q, it'll keep doing what you tell them to, what you wanted it to do. So there's lots of times when you'll use this repetition where you'll be looping through data, or looping through user input to do the same thing. But then, like I said, where it gets complicated is when you have sequential statements and then a decision, and then inside that decision, if this, then loop through this, and within that loop we do some more decision stuff, and then within that decision we do another loop, and it gets, it can get complicated quickly. But the silver lining to all that is that most of this analysis, almost all the analysis are straight line commands. They're literally opening up a file and using a command to draw a chart, or beg your pardon, using a command to provide you the mean of a column in a data frame or something like that. So we'll be using a lot of sequential statements, not almost exclusively, but I would say the strong majority will not be brain twisters, but you kind of got to know how this stuff works to do some of what I have seen other analysts working on. Okay. Man, I'm really getting dry and tired. Let's see where we're at here. Basic commands and features. We've already done hello world. You see, pound, space, and then a comment. You are always going to want to write good comments. You get too many commands going, too much logic going, and it's just really easy to forget what it was you were doing and why. So make sure you're commenting your code, particularly if you're doing the course final project in Python. You can start a line with a comment, and this gets ignored by Python. So a comment is there literally just for the human being reading this. And all languages have comment characters. Python's just happens to be a hashtag, pound sign. And you can also end a line like this comment here is on the same line as the print command, but it still gets recognized as soon as it sees that pound sign, that hashtag. It realizes it can ignore the rest of the line. Okay. And then we get to the concept of variables. I think this is a good time to end the day. But I got to get through a little bit more of this before I can start giving you hands-on sample problems. So, yeah, I'm going to stop here. So, like I said, I'm trying to find an Excel data wrangling guru that can give you more practical examples. In lieu of that, I'm going to force you to watch a couple of 15, 20-minute videos on YouTube that I have watched and found useful. And then on Thursday, I want to talk a little bit more about this cumulative Excel project and what you guys are going to do for it. Like I said, my idea was to use a 50-row data set of the United States, and then have you guys go in and just play show and tell with some different variables, different things about those states, whether it's funding levels in government or demographic information or geographic information. But I was hoping that would be a useful exercise to to clean the data, to go and get lists of things about the states and cut and paste columns, but as well as some basic charting and basic analysis and some storytelling. That's the other thing. I'm there's trying to make sure you guys are okay coming off mic and actually presenting. So I'll put some more work on that part, the instructions for that assignment. Meanwhile, like I said, I just lined up my buddy Dr. Ellis at the University of Central Arkansas to go through the Pandas analytical library. I think we're going to do that June 8th. Meanwhile, I will continue the quest for meaningful hands-on work in Excel before we start dealing with SQL and whatnot. If any of you are, Laura, you said you're in Excel every day. If you are tempted to rescue me from stumbling through this part of the curriculum, you're welcome to. We're all learning adults here, so if there's a particular exercise that you guys are going through, or in cleaning and analyzing data, please feel free to share that with the group, and I'll just continue on to make sure that we're covering the absolute fundamentals of this stuff as we go through. But really, Python's really my favorite thing to teach, if you haven't found that out already. Okay, so man, full 4 hours. Is there any? I made a couple of notes. Any open items? Any questions? Concerns before we come back together on Thursday morning? We'll continue with a little bit more statistics, as it were. I wanted to cover bivariate analysis, where we're talking about correlation values. Going once, twice. Okay, guys. We'll see you Thursday morning at 8:30.
Okay, bye y'all.
Thanks, Dawn.
Bye, everyone.